The purpose of this experiment was to produce hydrogen gas and observe its reaction with a heat source. The materials for this experiment included sodium hydroxide, a scoop, a balance scale, a crucible, beakers, a glass bucket, test tubes, a flask, an aluminum strip, a rubber stopper with a rubber hose, a lighter, and water. The procedure for this experiment began with the gathering of materials and then measuring the components to begin the gas production. The aluminum strip is inserted into the flask, and then the flask and glass bucket are filled with water and the test tubes are submerged. The sodium hydroxide is added into the flask and mildly stirred. As the bubbles begin to come off the aluminum, put the rubber stopper firmly onto the flask opening and put the rubber hose into one of the test tubes in the glass bucket. When the test tubes are mostly filled, slowly lift it out of the water. Ignite the lighter and quickly light the end of the test tube and observe the reaction.
Producing oxygen gas. For this experiment, you need manganese dioxide and hydrogen peroxide. You'll need a lighter, bucket, test tubes, and a flask. Submerge the test tubes in the water, making sure there's no air bubbles. Insert the rubber hose of the rubber cork in the flask into the test tube. The flask there will be held manganese dioxide and hydrogen peroxide, and it will create the gas and a bubbling effect. In this experiment, you light a wood splint and blow it out quickly while someone else holds the test tube inverted with their thumb over the opening. When you're ready, you place the wood splint in the test tube and watch the light grow brighter.
You realize that the oxygen is heavier than air, so
The purpose of this experiment was to produce the gas and see how it reacts to a heat source. The materials for this experiment were as the following: candles, beaker, vinegar, baking salt, lighter, and a glass bowl. The procedure for this experiment was to first light the candle, place the beaker in the glass bowl to avoid making a mess. Third, pour a small amount of baking soda into the beaker. 4, pour the vinegar into the same beaker with the baking soda. 5, tilt the beaker into the side just slightly above the candle. Make sure not to spill out any of the liquid onto the candle. 6, observe the flame. We repeated the procedure multiple times and changed some of the variables. The first time we poured the gas, the flame went out, but the second and third time it did not. The fourth time, however, it did.
Put it right in the
Give that a
Very
date.
hard. No, he can grab it.
Where's you at?
Where's the what?
We got that chemical though.
You gonna put it in the vinegar?
Yeah, it did.
So now what?
I don't know.
Now we do something with the candle. I just don't know what to
Do
do.
What if I put the candle in there?
What did you see in that lab?
tilted it over.
Where's the gas going?
Up.
No, not the candle.
Oh,
Not the
I was
candle.
like, okay.
You're gonna.
This?
it's
Your whole reaction's gonna be done.
Right? Is that? Really?
Don't-
Whoa, that was cool.
And it reacted in a way where when you lit the end of the test tube, it would ignite the gas throughout the tube and come back out the opening with a high-pitched whoop noise. This reaction happened because hydrogen is a very reactive element that has a single electron in its structure.
The second reaction was with oxygen, and it reacted with the lit wood splint by causing it to glow brighter. You would know the gas was gone from the test tube when the splint goes out. This reaction happened because oxygen is required to make fire. Fire is burning, which is combustion, and combustion is a type of oxidation reaction. Oxidation means combine chemically with oxygen. Oxidation is an exothermic reaction, meaning it releases heat energy.
The third reaction was with CO2 or carbon dioxide, and unlike the others, it put out the fire. This reaction happened because fire needs molecular oxygen to burn, which means O2 molecules. In CO2, the oxygen is bound to the carbon, so it is not available for supporting combustion.